I'm CK. Today we've got another one from Whadda, Velleman. It's a signal tracer injector, so it's basically a little signal generator that you can use to trace another circuit to see if things are getting to where you want it to be. Hopefully I have an amplifier around here somewhere that we should be able to probe and trace, but I can't find it. I know it's around, I'll find it. If not, we'll just show it on the oscilloscope. But very useful tool for seeing whether your connections are getting through and whether your transistors are transisting and so on. So we'll put it together, see what you learn from it, give it a little test, and I hope you enjoy the video. Let's see what we've got. A typical Whadda box, plain brown with a wrapper around it, measuring instruments, meter, soldering, level 2. It's a level 2 soldering kit, so it's not flat out basic. Compatible with amps, radios, tone controls, yeah. Injector, detect a specific signal, or detect. That's interesting. Takes 12 to 9 volts or AC, or 7 to 9 volts AC, or 9 to 12 volts DC. 150 milliamp. So that takes a little bit. Outputs 5 watts at 8 ohms. Then we've got circuit board, a decent number of components. Let's see what's in here. Slide the outer wrap off. Online manual, so we'll find the instructions there. We'll get the box ready for recycling. Here's the circuit board. Pretty straightforward. We've got 2 variable resistors, an IC, bunch of capacitors, bunch of resistors, some diodes here and there, and then these I think are going to be the output points, but we'll see. As you may be able to notice, there are no values listed on the board or marked on the board, so we'll definitely need the build guide. It's a single layer board with just little copper traces, very easy to see where things go if you want to trace this by hand. Hopefully they have a schematic in their online manual. Inside the bag we've got our resistors and diodes, power protection diodes, and another Zener here that I don't know what it's for, but we'll see. Velleman usually puts these in order of assembly, which is handy. Get the caps out. Got some disc caps. They're all 103s. Pots with big long handles. These are not, oh, that's 4.7K. Man, I'm having trouble with this bag. I don't know why I'm having trouble with the bag. And this one is 4.7K. It's probably to set the power and possibly the frequency too. Here we have some pins, which I think that will be where we'll connect our probes that can go into the circuit under test. Here we've got 2 more disc caps that I can't read. Oh, these are 104s, so they're decoupling caps for the IC. Let's see what the IC is. It might be a 555 to generate a frequency in a pulse. It is a LM386. That's an op amp. That's an audio op amp. That's interesting. I wonder why they're using an audio op amp for that. We'll figure it out. Should have some transistors then, or at least one. Yeah, we do have transistors to get the oscillations going. And we've got, let me just dump these into my hand because this bag is driving me nutty. I don't know why. Nothing else in the bag. Some nuts and washers. So I think if you make this, you could always put it in a little box, and then you've got nuts to secure it to the project box. Some foil caps, some more electrolytics, the socket for the op amp, and then should be two 547s. Yep, two 547 transistors, which would generate the oscillating circuit. So that's it. Looks like it'll be pretty straightforward to put together. Let me get the soldering iron heated up, and we'll go ahead and do the putting together part. So I brought the build guide up from Velleman's website. Now, if you're doing this in English, don't click on the English build guide instructions, because that won't bring it up. Click on the English user manual and it'll bring it up. And it's a standard little Velleman type build guide, black and white, nothing too surprising. We're going to start with the Zener and put that at ZD1, and that'll give us, and remember, polarity here is there's a black stripe here and a white stripe here, and they match. Come on. I just played 3 hours of Elden Ring, so my thumbs are a little tired, a little shaky from whacking monsters all morning. Now we'll see how this board takes solder. It's okay, though there is a little haloing. Let me see if I can get, oh, it didn't halo that time. I'll show you what I mean by haloing in a little bit, probably on the resistors. But it went together just fine. Now we're going to do the other two, the 4007 diodes, which are for polarity protection. And again, there's a silver stripe here and a white stripe there for D1 and D2. So what I mean by haloing on, it's particular to through-hole builds, is sometimes the hole is a little bigger than the wire, and the solder will form a ring around on the traces on the board without actually touching the wire. And you can just watch for that. Again, if I can catch it here. Did I do that wrong? I did that wrong. I put that in the resistor hole. I was wondering, they're supposed to be side by side, and they weren't. You'll see a little halo around it, and you want to go back and reheat the solder or add a little more solder and let it flow through. Now I got those leads a little kinked, so I'll use my needle nose to bring them in. Double checking polarity before I solder. I'll solder these two guys. These may halo, I'll see. That one didn't. I'm trying to have an instructive minute here, Kit. So that's all of those. Now we're going to do the resistors, and there's just a list. And again, since we're going from this direction, they should all be in order. So the first one is a 220, and as you can see, it's red, red, brown, gold. So that's going to be 220, as we know from our handy-dandy color card if you don't have them memorized. I'm sorry, 22 and 10. And we'll just put all those on, and there's not much to say on these because they pretty much go together like everything we've been talking about so far, except the resistors, of course, are not polarized, so you can put them in any old way you want. Get our 3 3s out, so I will continue to put all these on, and I will speed up the video playback, and turn off the commentary so you can enjoy resistor time. Okay, I'm going to stop right here, and as you may be able to see here, let me zoom in on this and make sure we can see it. Get my pointy thing. Right here on, I'm sorry, I'm looking at the camera. Right here you can see it ringed. It didn't make a solid ball like that, it made a little ring, and you might think it's soldered properly, but it is not. So let me go back out a little bit again. And what you just want to do is touch that up again. Just put a little more solder on it, or even just reheat it. Now back to our regular scheduled resistor time. So there we all are, and resistor time's done for today. One thing I do want to point out, because this is a through-hole board with a single layer, you don't want to do what you might do on a through-hole board, which is cut it even with the circuit board. No, you want to cut the wires above, just right above the solder bead, so you don't run a risk of pulling up the solder pad or just cutting too much solder off. Also, you don't want to pull. Now, vellum boards are pretty good quality, so I'm not too worried about that on this board, but it's just a good rule of thumb. The other thing, as a rule of thumb for me, you may want to do this, you may not. I always put resistors with the most significant digit on the left or up when I'm doing it, left or up, so that when I glance at a board, they're all facing the same way. I know which way they're facing, so I can quickly figure out the values without confusing myself as to which way is this in. Now we're going to put the socket on for the op amp, and it goes here. There's a notch on the board, there's a notch on the socket. We'll just set that on there, try and put it down without it coming out of the holes, and I did. But what I'm going to do is I'm going to solder one leg. Now pick it up, and as you may be able to see there, the socket's not quite flat, so, and I knew that, so I'm going to put my index finger on it, reheat that solder, push down, and now it's all flat. Do one leg, take a pause and look at it, and then move on. So that's the socket. Now we'll put the capacitors on. We've got our 103s, which are 10 nanofarad, and don't try and pull these out of the paper tape, just cut them out of the paper tape. If you try and pull them out, you'll twist the leads. You could potentially even damage one of the capacitors or components you're working with, so just be careful. C1 is somewhere on the board here. Come on, where is C1? Well, here's C2. There's C1. C2, well, C1 is below C2. Well, that's not very exciting, is it? Now I'm going to flip these this way so they don't interfere with C3s, which I'm going to do my standard way. No, I'll do it that way too. Never mind. Now we'll get the 200 farad, 100 nanofarad, the 104s. These are decoupling caps for the IC to help condition the power going into the IC, preventing dips, preventing some noise. You can read up on what decoupling caps do, many online resources for that, but they just ultimately keep the integrated circuit happy with its power. Now I'll solder all these caps. Caps are on. Now we'll do our transistors. We haven't done the electrolytic caps yet, or the foil caps. So now we're going to do the transistors, and they're both the same. And where the heck, there they are. There's 1 and 2, and as you can see, flat spot on the transistor, flat spot printed on the circuit board. They need to match. That means we got to bring the center pin back. Different board layout software will sometimes bring the lead forward, sometimes bring the lead back, sometimes leave the leads in a row. So just be sure you can see what convention the kit you're working with is. Transistors are on. Let me see how much time I have left on the camera. That's just 10 minutes left, so that should be fine. Now we're going to put the tabs on the PCB, which are these things, which are the various connections we're going to make to our test circuit. Now, you could do them one at a time, but I'm going to try, oops, no, I did that right. Could do that one at a time, but I'm going to try and be clever. I'm not going to do, there are 2 input ones over here. I'm going to do the output ones first. I'm sorry, I don't know where power is. I'll have to look that up when we get to that point. So I'm putting all these guys in. Some of them will stay. That one, for example, was very thick, where the hole was not drilled as well. So I'm going to take these away. It looks like they gave us an extra one, which is always nice. I'm going to put these in my parts tray so they don't roll off. Now I'm going to take this little card and I'm going to flip everything over like that so nothing got away from me. And now I'm going to take some thicker solder. Put my pinky finger down, or my ring finger down, to keep things flat on the board. I'm just using thicker solder because these are widely spaced and I don't have to use as much solder. Okay, now we'll do our other ones. Ground and out, and I think that's all. Again, I think they gave us 2 extras. Those are staying in pretty, nope, I lied. I said those are staying in pretty good, and then I turn it over and they both fall out, of course. I think they gave us an extra one because, again, it's pretty easy to have these go, God! What are you doing there, buddy? I didn't flip it over right. Because they will roll off your workbench, and if they roll off your workbench and you have a stained concrete floor in your workshop like I do, then they can vanish. And I did let, oh no, I got them, oh, come on, I had my finger in the wrong place, or in an inappropriate place for getting the right purchase on that. There we go. Those are all on. Now we'll do the foil caps at C4 and C5. Interesting, they have 2 holes for one of the legs because I guess they're not quite certain what manufacturer they may get their parts from, so they're offering 2 sets of holes. The 2 holes on the right, as I'm looking at the board, are connected together. So don't worry if you've got 2 holes open. When you get done with the kit, you will, because you're using one or the other at this position here and this position here. Okay, I'm not going to trim those right now because I'm lazy. Looking at my clock timer again. Okay, 6 minutes. Yeah, we can do this, the rest of this in 6 minutes, can't we? First we're going to do our electrolytics, and they are polarized, but first let me get the right ones. That's 47. What do we want? We want 1 microfarad. That's a 470 also, but that's a big one. Where's the 1 microfarads? That's 100 microfarad. I should probably sort these, shouldn't I? There's 1 microfarad. So one lead is longer than the other one. The long lead goes in the position where it has a plus sign by it. So that will be for C8 on that one. Now we'll grab the other one. 47 goes in C10, and that, the plus side is going down where the other two we just did are going facing, or at the upper hole, so you just want to be careful about that. Now we do our 300s, and that's C11. Now I'm going to solder these, but I'm going to turn off the cameras because they're about to hit their time limit for one recording session back in a flash. Capacitors are all on and soldered correctly. Next thing they would like us to do is put the op-amp in, and I'm going to bend the legs in a little bit against the side of my workbench and make sure the notch matches the notch on the socket, which matches the notch on the printed on the circuit board, and I bent them in a little too much. So take my needle nose and bend them back out a little bit. Using the needle nose on all the pins at once, make sure they will be parallel. And there we go, it goes in. It's not quite level. Let me push a little harder. Let me futz around with it a little bit because it's not quite in. It's making contact, so it would work, but I don't like it. Much better. Now it's flat. And again, I'm surprised they're using an LM386 on this because they're higher quality op-amps generally used for audio, and I wouldn't think you would need that level of precision. So now we've got RV1, variable resistor or potentiometer, and RV2. RV1 takes the 4K7. And I'm going to solder that right now. Again, I'll use my heavier solder for this. And I'll do 1 pin because it's not quite perpendicular. And then I'll reheat that solder, make it perpendicular. Wait for the solder to cool, or else you make it perpendicular, let go of it, and the solder is still flowing a little bit, and it'll just move back to where you were. I have done that many, many times. Now we have the... Wait a minute, did I put the wrong one in there? I put the wrong one in there. I put for the 47K in there because I'm an idiot. So we'll just pull that back out. Now we'll put the 4.7 or 4K7 in. Again, single layer boards with no through-hole plating. Rework like that, as you saw, is really pretty simple. Just reheat the leads and use your solder sucker. Now, one thing, they have little holes here for to either mount it on a board or put it in a box or whatever. They didn't give any spacers or anything on this one. They often do, but they didn't this time. So that's it all built together. One thing I'm going to do now, which I usually do, is I'm going to look at all the solder connections, make sure that they are all appropriately soldered, and there's no bridging or shorting, and they all are. So that's it assembled. Now I'm going to turn the soldering iron off, and then we will oh no, I'm going to leave the soldering iron on. I'm sorry, because I'm going to be doing some stuff that they don't necessarily do. And I'm going to go get a power supply and some other stuff to actually set this up, and an oscilloscope. As I said, I couldn't find the amp that I wanted to use to do the actual signal injection and trace it through. Maybe if I can find it someday, I'll redo that. But let me show you what I've got here. We've got power coming in. I'm using 9 volt from my little power supply. And then this speaker will let you hear what's going on, what the signal should sound like. I soldered the wires onto LS, which is the positive side for the speaker, and ground to black. You could clip them on or solder them on. It just was easier enough for me to solder them in place. And then the little speaker right here. Then we've got the output signal. There's the ground. There's the main signal. And let me bring up the oscilloscope on the screen. In other words, and I'm going to move this over a little bit, so because I know when I edit this, I'm going to have to put the oscilloscope trace like right here. So both potentiometers are at 0, and when I bring, this is for volume of the speaker, this is for amplitude of the signal. So I'm going to turn volume of the speaker all the way up. And that's what the op amp is for, is to broadcast the speaker volume. Now I'm going to start bringing the amplitude up, and as you can see on the scope, it's starting to go. There we go. I can't hear. Oh gosh. Let me put the microphone right on top of the speaker. You may be able to hear something. I can barely hear it. I don't know what I guess the point of the speaker is so you can verify that what you're hearing in your circuit is what you're seeing on what the output is. But that's what it does. So it's just generating a sine wave, as you can see here, and the frequency, if you'll look right here, the frequency is 1 kilohertz, so it's kind of low. But what you want to do is you put these inputs into, say, the microphone input or the whatever signal input you've got in your circuit, and trace it around, see if it's hitting the transistor, see if it's hitting there, because you should see this same waveform wherever you, along the circuit, wherever you touch your probe for your oscilloscope. And it's, you know, was $15 US instead of getting a $50 or $100 signal or function generator, even though I've got a couple of buildable function generators you can use for the same thing on the channel. I'll try to remember to link a couple in. But it works, and again, you can change the amplitude, and that changed the frequency. No, it didn't. I don't know why it's wrong. Oh, I don't have the button on it correctly. What are you doing? There we go. Oh, it just keeps killing me on roll, but that's okay. So that's what you get. You get a little variable signal that you can trace through a circuit at various amplitudes to see if the circuit, where a component might be not working, or where something's mis-soldered or grounded or something like that in another circuit. This is a tool to help you gosh, you can really barely hear that. And this is a 4-ohm speaker, which is what they recommend. But that's fine. So that's it. A good little practical tool to use. I just realized I forgot to talk about the schematic, and or maybe I did, but I'm going to drop this in anyway to make sure. So we got a couple of things here. First thing we have is the power coming in, being conditioned appropriately. Here's the speaker circuit with the input from the output of the little oscillation circuit, and variable resistor there to control the volume, the op amp to drive the speaker. Then over here we have the signal generation, which is a simple transistor oscillator going out to the output and to ground, and there's the variable resistor which controls the amplitude of the signal. So that's it. I just wanted to make sure I captured that. So back to, I guess, the conclusion of the video. And that's it. And it's another good kit from Velleman. And I hope you enjoyed the video.